Welcome back. I hope you had a great break. Just a quick reminder, at 1300 Central European Time, things will also be happening over in hybrid space. But now we will hear a keynote on quantum computing and machine learning. Our speaker asks, is this a dream team or just the next hype? As if one would exclude the other, I might say. But I'm very curious what the head of AI and ML at Telekom Innovation Laboratories has to say about that. She's a member of the Bitkom board for artificial intelligence. She's a big contributor to Berlin's startup ecosystem, and she was honored as one of the global women leaders in AI. Give it up for Claudia Pohlink.
All right. So hello, everybody. And first of all, I would like to thank you, Veronika and Fabian, for having me here today. And my deepest respect because you transformed this physical event into a virtual. And this is so great, so amazing to all of you and also the team, I think, that was behind. So congratulations. Yeah. All right. Quantum computing and machine learning is the title. Dream team or just the next hype? Yeah, so today I would like to take you with me on our journey at Deutsche Telekom. And this means this is a journey to enter a new technology, quantum computing, quantum machine learning, quantum technologies. And I don't know if you have ever wondered how a new technology enters a large corporation. And today I would like to do some whistleblowing, or in German, aus dem Nähkästchen plaudern. 2 years ago, we evaluated AI trends to detect the next white spots for us, because we are working at the R&D department, and our horizon is 3 to 5 years, sometimes longer. And our job and our mandate is to explore new things on the horizon. Yeah? And then in the cluster devices, quantum computers popped up. And then we checked this in our team with the experts and the usual suspects, and we decided just to dive deeper in this topic. So let's just start. And why am I telling this to you? When you would like to start a new topic, and I mean a new research area and a new research topic, then you need persistence, curiosity, and also imagination. First of all, you have to see the potential and not having all the time numbers or KPIs in your mind. This is my first takeaway for you. So I won't talk about how a quantum computer works. To be very honest, 20 minutes are far too little. Yeah. So I brought a nice quote from Richard Feynman to you. He is a physicist, or he was a physicist and Nobel laureate. He said, I think I can safely say that nobody understands quantum mechanics. So do I. And this quote is still valid. Yeah. So what I would like to give an overview today is how we observed this new technology and how we explored use cases, how we can transfer these use cases into our business, and what will be the next level of this whole technology. Yeah? And quantum is quite a large field of science. So including chemistry, biology, also some other stuff which is called quantum sensing. Yeah? But we at Deutsche Telekom, we focus on quantum computing and quantum secure communications. Quantum secure communications is about keeping communications safe, where keys are secure today and could be broken in milliseconds. And quantum computing, this is not only about hardware. Quantum computing, let's try understand it very simple. Quantum computing is about transforming complex combinatorial problems into this new world of quantum physics with the help of algorithms. And I mean you have to program algorithms in another, completely other way. Yeah, so you have to think in energy functions. And when you implement these new algorithms on a computer or on a quantum computer, then you have the hardware as well in the field. And today I would like to focus on the field of quantum computing to make it very simple. Yeah. Okay. Again, this is not only about exploring a new technology and play around. This is, of course, to find use cases. Yeah. So complex problem solving is becoming much more efficient than with classical computers. So that's why let's try to see, or let's scratch on the surface. Yeah. We all know classical bits, where we have states either 0 or 1. So far, so good. The counterpart in quantum computing is a qubit, the quantum bit. And the quantum bit can also have the state 0 and 1. But the huge difference is that the qubits have this state at the same time. Yeah? So this is called superposition. And by the way, this phenomenon is unusual. This phenomenon, this effect, this is the game changer. What I think. So let's just take another classical bit. You have 4 states, 0, 0, 0, 1, for instance. And if you have 4 numbers, 4 states, then there are 16 combinations possible. And you can only use 1. With a qubit, you can have all these 16 combinations at the same time. And if you add more qubits, the growth is exponentially. So if you have 20 qubits, so this, let's say, computer is able to process billions of data or states at the same time. And this is, let's be very honest, this is the magic behind the quantum computers. There's also another effect or phenomenon, this is called entanglement. Entanglement is the connection between the qubits. So it means that if you change one state on a qubit, the other qubit reacts instantly. Yeah? So entanglement allows qubits that are separated by incredible distance to interact with each other instantly, also on long distances. Yeah? On the right-hand side, you see also some more differences, but let's stay here. The most important thing, what you should know is, it is about speed effects. And we would like to focus at the moment, and I'm talking about our, let's say, status in our R&D department, we are exploring optimization cases, yeah, because when you have complex mathematical combination problems, this is about optimization. Yeah, so our goal is to find use cases with the goal of optimization. Okay, so this is an example to understand this complex stuff better. Yeah, routing optimization, and this is also known for a long time as this traveling salesman problem. Yeah, so routing optimization is not only in networks, it's also in logistics, field service, navigation, and so on in the traffic. And this routing optimization is influenced by different factors. And then we have the, let's say in our case at Telekom, network points. Yeah, you see this table. We have 3 network points, 6 combinations, 4, 24. And if you have 20 network points, you see the number. This is just to illustrate the amount of combinations. And in this case, traditional computers reaches its limits. Yeah? And what you can also see here is just a visualization. Yeah, I love visualizations with complex technologies. This could be also a navigation from, let's say, a salesperson who would like to drive to 20 different locations. But with quantum computers, you will be able to also use other factors for this optimization, because you can also include speed limit, traffic lights, air pollution, and so on. This is not possible right now. So here's the second takeaway. It's not only about speed, it is also about building solutions which are not possible yet. And this is again about imagination, because you have to think completely over the horizon. Yeah? So you have to find completely new problems. As I said, quantum computing will not substitute classical computers. That's the third takeaway. But it is restricted to certain types of use cases. And I brought some use cases with me. You can see on the left-hand side industries. You can see here already the companies who are in the making, and on the ground you will find the telco use cases. So this is not only about optimization, but let's say we will focus right now on network optimization, for instance. But customer classification would be also a use case. Of course, fake news, quantum key distribution, quantum safe encryption, service scheduling, edge computing, network anomaly detection, and so on. Yeah? So there are a lot of use cases out there, not only for us, but most of the companies, and this is the good news, are already working on these use cases. One step back, if we talk about quantum computers, then there are three different types. On the right-hand side, you see the classical quantum gate computer. I mean classical because this is the biggest thing, and you may have heard of. Yeah? IBM, Google, this is the gate computer. On the left-hand side, we have this quantum simulator from the company D-Wave, the Canadian company. And in the middle, you will see, or you see this funny name, digital annealing unit from Fujitsu. And this is a so-called bridge technology. So this is quantum inspired. And this is important if you want to choose your use cases. Yeah? Let's just think in edge computing. So this gate computer, of course, you cannot transport, as well as the other one. So most of the, let's say, bigger quantum computers are or can be accessed via cloud. And the future of quantum computing will be in the next years cloud business. Yeah? But if you see this chip, this is also possible to implement in networks, and you can distribute also the load of your networks, for instance. Yeah? So you would be able to distribute the whole power of computing. Yeah, federated computing, whatever. So I don't want to make ads here for Fujitsu, but this is just an overview about the technology right now, yeah, the hardware. Okay, and again, if you have identified the use case or the problem class, then there are three different, let's say, characteristics, or should be. It is a sufficient problem, complex problem, recurrent, yeah, and you expect a near-time response. And on our journey, I can tell you, we identified some use cases, and then we found out, okay, this is only done once a year. Therefore, you don't need a quantum computer. Therefore, you can, of course, use all the other old stuff. Yeah, and then you can also see the mentioned use case classes, problem classes like this Knapsack problem, the traveling salesperson, routing problems. And then here in the field of quantum gate computers, then we come to the quantum machine learning, yeah, Grover algorithm for search in huge databases, where of course Google will have his biggest hope, yeah, or the Shor algorithm for prime number decomposition. So there are a lot of stuff out there, and you have to, let's say, find a way through the jungle. This is our, let's say, one of our first use cases. This is about frequency assignment planning. And you see mobile network towers. And at the beginning of every use case, you have to define the optimization goal. And this is similar to data science cases. So you need the scientists, but also the domain experts. Yeah? And then it could be an optimization goal. Firstly, maximize number of allocated frequencies to meet the traffic demand. And we are talking right now about 2G, not 3G, not 4G, not 5G. Our case is in the field or in the frequencies from 2G. And maybe you can imagine 5G will be much more complex with this assignment of frequencies. Yeah? And the second goal is minimize interferences, because this is one of our biggest challenges, to minimize the interferences. Yeah? So we just derived this Hamiltonian method. FAP stands for frequency assignment planning. Sorry for all the short abbreviations. We run that on a quantum annealer and benchmarked this result against, let's say, classical algorithms, because of course we are doing that already. Yeah. So in every case right now at DT, you have to compare the classical method against the new method. And it could be that the result will be, okay, it will not support, it will not help. But then you have to search again. This is the game. Yeah. What I also brought with me is an overview of the ecosystem, and this is just because to give you the feeling that we are talking about computers. So there are also layers, the hardware layer, the system layer, the application layer, and also services. Yeah, so we have, for instance, end-to-end providers like IBM, Google, which I already mentioned, or the hardware players, the software players, and also some startups and specialists. This is also good to know when you work with partners or vendors. And as I said, it will be a cloud business. And you see all the global players here already on the chart, which is a sign. Yeah. And this is also just an information for you to see, okay, this is from 2018, by the way. There are a lot of languages in different layers. And I just mentioned this new TensorFlow quantum library from Google. Yeah, so you can try out a lot right now. This is not scientific anymore, science fiction anymore, and also not magic. You can try out a lot. And when it comes to quantum machine learning, it's very hard to say what is quantum computing and what is quantum machine learning. So again, I tried with a visualization. Yeah, you see on the left-hand side AI and ML, on the right-hand side quantum, and the, let's say, how do you say, overlapping thing is quantum ML. Yeah, I like this quote on the right-hand side. Quantum machine learning allows scientists to take the classical machine learning algorithms and translate it into a quantum circuit so it can be run efficiently on a quantum computer. So far, so good. Yeah. So to be very honest, there is not this typical quantum machine learning. So you'll use a lot of your machine learning knowledge to try out the first cases, because you need also Python, by the way. And this is another challenge, not only for the field of data science and machine learning, when we think in talent wars. When this technology is coming, we do not only need machine learning engineers, we also need the knowledge, or this should be combined with physics. Yeah, so start as early as you can. This is my recommendation, also with building up the knowledge and with finding or hiring talents. Yeah. And this is my last example for today. When we explore quantum machine learning, there is no starting point. Yeah? So first of all, we have to learn. And we used here this example from Hartmut Neven from Google, and it is about breast cancer detection and on X-rays. This was the classification goal. And we just tried to copy and to learn how we can do that, how we would do that. Yeah, so, and this is just the formula for the quantum annealer, I think, in this case. And here, this is the comparison of the results. Yeah, you see here classical methods, and then you can see also the new method. Yeah, so, and what would be the result? So at the end, you have to explore a lot. You have to stay on your, let's say, imagination that there will be potential, and you have to find the specific and dedicated use cases, not only in the field of optimization, but also in the field of classification, segmentation, and cryptography, and so on. Yeah, so that's what would be my recommendation to you. And at the end, dream team or just the next hype, I would say, of course, a dream team, and we have to start. Okay.
Thank you very much, Claudia. I don't have questions from the audience yet, but that's maybe because nobody understands quantum mechanics and maybe also not quantum computing, although I was impressed.
Thank
For
you.
somebody starting with a Feynman quote, you seem to understand a lot about quantum computing. So that's much more handleable than the raw physics of it, obviously. You were talking about the different players that emerge. Which type of player is Deutsche Telekom? Do you know yet what type of player you are?
We are already working with players.
Right.
Sure. Yeah. So, and I read an article about BMW, I think some days ago, and they had the same journey as we had, but they, I would say, 2 years advanced than us. And they started with the same technologies, with these annealing stuff. Yeah, this is about optimization. There you can use the annealing technology, which whether it is D-Wave or Fujitsu. And now they turned their, let's say, bigger cases into the quantum gate computing area. So now I think they're working with the bigger ones.
Right. And you gave some advice at the end. You said hire talent early and start early, start learning. Was that advice you gave yourself as well?
I'm happy as I am. Yeah.
Right. Okay. So where are you in the talent wars? I mean, you obviously have a small but very qualified team, but I think Deutsche Telekom as a whole will need a lot more specialists, right?
Yeah. Look, we started the whole journey 2 years ago.
Right.
And this means right now we identified a small community within DT, and the community are 10 people.
Right.
To be very honest.
Right.
Yeah. 10 people who are really in the topic and understands the quantum mechanics. Yeah.
Which is not bad for today. 10 people who really understand is great.
Of course, yeah. And the other colleagues started already with quantum key distribution. This is much more advanced right now for us in DT. Yeah. But we also have to develop this vision for 2030.
Right.
Yeah, and our vision will be to develop a quantum internet. Yeah, something in that direction. Yeah, so have a lot of players, and I think this is not just a revolution; it will be an evolution.
Right.
Yeah.
And you said that you're working with the quantum annealing things. I don't grasp quantum inspired stuff fully, I must say. But when do you think will you work with an actual quantum computer or with computing time on a quantum computer? Because you probably won't get one right away, right?
I think next year.
Next year?
Sure.
All right. And which type of computer will it be? Can you disclose that? Do you know already? Or
there's this nice race between IBM and Google. Yeah, This is about the number of qubits which you can use. And IBM just announced, I think also some days ago, that they will offer, I think, around 1,000 qubits in 23.
Right.
Which is amazing.
Right. And
this is interesting.
Are they, I mean, do customers already line up, or is it that they're rather looking for people willing to put in the money and the work and start using that?
Yeah, there's another information. So I had also IQM on this ecosystem chart. And IQM is a Finnish company. And they announced this Monday that they will develop the first quantum computer in Europe.
Right.
And of course, this is a nice development, yeah. But if you develop hardware, you always need the applications and the use cases. So that's why they are also interested in our stuff.
That's really interesting. Apart from the frequency distribution and the interferences, are there other like practical things that at least you, maybe not the whole of Deutsche Telekom, but you think you will solve with quantum computing in a couple of years?
Yeah, so when you navigate through the city, for instance, or through the country, you will always get a recommendation from every navigation system what you have installed. Take this way or this direction, from A to B.
Right.
And sometimes you're coming into this traffic, how do you call it?
Traffic jam? Yes.
Traffic jam, yeah. So then you get an alternative route, yeah, and you choose this one alternative route, like all the others behind you.
Right.
So how about just also distribute the traffic and giving all the car drivers or the whole traffic alternative routes? You can use the whole city or the whole country.
Right.
Yeah. This is the holistic view. This is not possible right now.
No, really interesting. I want to try to relate to things we heard this morning and also yesterday about the management and leadership having to deal with like really new and not to people mention it, but this seems like a really technology with a big disruptive potential, right?
Sure.
So how is your upper management, how are your CXOs at Deutsche Telekom looking at these things? Do they call you every day? Do they have it on their minds?
As I told, it was a journey.
Right.
So this is not only about...
It still is, right?
Sure. This is not only a playground.
Right.
Yeah. And you have to convince not only with ideas. Yeah?
Right.
So you have to present business models, and to be very honest, this is not possible right now.
Right.
You don't. If you ask IBM or Google or anywhere, don't get a serious business model right now because this is not possible yet. Yeah. So and that's the hardest part.
Right.
Yeah.
But as some speakers mentioned, it is maybe time to do business a little differently and explore stuff before you have a business model, right? So is this part of your work to convince them that this is the time for behaving differently, doing stuff differently?
This is about a mindset change,
Right.
Yeah.
And
you have to believe in your experts, and you have to, let's say, identify the potential and imagine what will be possible in the future. And then maybe you have also to inspire your CXO or whoever.
Right. And we also had the idea today that it would be very fruitful to have some maybe non-executive board members from different technological realms. Is this a topic that is discussed at Telekom, or would you like it to be discussed?
First of all, I would like to start with trust.
Right.
Yeah. So I'm not talking about that I'm not trusted, so this is not the thing, but I think we have to change this mindset also everywhere, give them the chance to explore such a new technology. And also if you see the other companies, the big players, and I mean everybody is already dealing with quantum computing, there must be some potential.
Sure.
At least you can trust them.
Right. But that's, of course, the difference between, we have to do something in an area because everybody is doing it, or like really allocating the resources, right?
And the same with data science use cases. Yeah. So we had that 10 years ago, the same situation. Yeah. So you have to start small and think big.
Right. So let's not talk about your management's vision. Let's talk about your vision. Like in 5 or 10 years, if everything goes really great, what would you be doing at Deutsche Telekom regarding quantum computing and machine learning? What do you think?
More AI and quantum computing research.
Right. And would you still understand how it's done?
No, I think not.
But you could probably understand the results.
Try to explain, yes.
Right. And what are your personal plans? Are you planning on visiting any physics lectures in the next month? You already did?
Yeah.
Oh, that's very interesting.
We also visited IBM in the US.
Right, all right.
I saw this real quantum computer.
Right, so this is also an opportunity for lifelong learning.
Oh, for sure.
Great. Very exciting times.
Thank you.
Very exciting talk. Thank you very much.
It was a pleasure.
Have a lot of fun with quantum computing. Thank you.
That
Claudia
was the
Pohlink,
goal.
everyone.
Okay, bye.